Okay, hi guys. In this video, we will discuss about transformer ratio. Okay, the basic of construction of transformer is like this. We have a magnetic core, winding at the primary side and the secondary side. Okay. Okay, the transformer is a passive component, so it cannot produce more power at the secondary side than applied power to its primaries. Okay, primary side. Okay, so that means the power here, the total power at the secondary side is same as the power in at the primary side. It follows the law of conservation of energy, state that the total energy of an isolated system remain constant. Okay, so by considering this transformer is ideal transformer, so the power at the primary side is same at the power secondary side. Therefore, if the secondary side voltage, okay, this secondary side voltage V2 is greater than the primary side V1, if V2 is greater than V1, means that the current at I2 is less than current at I1. Okay, because the power is same, primary side and secondary side. So if voltage low, then compared to primary side, so the current high. Okay, vice versa. Okay, let's recall the previous equation. EMF is equal to 4.44 times flux maximum times frequency times number of turn. Okay, this equation we already derived in the previous video. This for E1. Okay, E1 is here. E1, E2 is here. Okay, E2 is for secondary, E1 for primary. So E1 is equal to 4.44 flux maximum, okay, Fn1. Flux is here. Flux. So we can see that flux at the primary is same as the flux at the secondary. So the equation will be for E2, EMF at secondary side is equal to 4.44 flux maximum. Okay, same flux. So frequency, same frequency, and 2. Number of turn at secondary side. N1 is number of turn. Number of turn at primary side. Number of turn. Number of winding at the primary, and is number of winding at the secondary. Okay, we have one equation, second equation. Okay, now we want to find the ratio, transformer ratio. Okay, we know that transformer ratio is equal to the primary, secondary divided by primary. Equation number 1 divided by, equation number 2 divided by equation number 1. So E2 divided by E1 equal to 4.44 flux maximum, frequency, and 2 divided by 4.44 flux maximum, frequency, and 1. Okay, this one is for E2, this one for E1. So we can cancel this one, this one, this one, this one, this one, this one. So we will get N2 over N1. Okay. Okay, ratio. The generated EMF at secondary side divided by primary side is equal to number of turn at secondary side. Okay, this number of turn divided by number of turn at primary side. Okay, E2 over E1, E2 over E1 equal to N2 over N1. N2 over N1. Number of turns at secondary. secondary coil. This one is number of turn at primary coil. Okay, this is ratio. Okay, by assuming V1 is here, E1 is here. We just assume there is no loss during this at this wire, no loss. So means that V1 approximate to E1. V1 approximate to E1. And also at the secondary side, we assume there is no loss at this wire, at this cable. So E2 will be equal to V2. Approximate. Okay? Oh, sorry. Okay. V1 approximate to E1, V2 approximate to E2. So by using this equation, we replace there. So E2 over E1 equal to N2 over N1 equal to E2 is V2, E1 is V1. Sorry, V2 over V1. Okay, this one is a ratio. We as a A. A is turn ratio. Turn ratio. Turn ratio is N1 over N2. Voltage ratio is V1 over V2. So A for A V2 over V1, N2 over N1 equal to E2 over E1. So this one is called voltage ratio. Voltage ratio E2 over E1, V2 over V1 equal to A. Turn ratio, number of turn is N2 over N1 equal to A. Okay. Okay, now normally transformer power rating of the transformer is the power rating of a transformer VA, volt ampere. Okay, power at primary side, VA at primary equal to VA at secondary. No losses, so the power VA here at primary equal to power at the secondary side. So VA primary equal to VA secondary. Okay, VA is volt ampere. For primary side, V is V1 times I1 equal to V at secondary is V2 I2. Okay, V2 I2. Okay, this one is VA rating at secondary. This one is VA rating at primary. So from this equation, we just rearrange it. V1 over V2 bring V2 here and I2 bring there. We got I2 over I1. Okay. Okay. So now we try to this one we call current ratio. Okay. So we try to compensate with this one, compare this one. Okay, the previous, this is number 3. Number 4 is E2 over E1 equal to N2 over N1 equal to V2 over V1 equal to A. This from this question. Okay, this one is a voltage ratio. This one is turn ratio. Turn ratio is N2 over N1. Voltage ratio is E2 over V1 or V2 over V1. So V2 over V1 means that from this equation it shows that V1 over V2 is I2 over I1. So V2 over I1 is equal to I1 over I2 equal to I1 over I2. Okay, this one is V2 over V1. V1 over V2. So V1 over V2 equal to I2 over I1. So V2 over 1 is equal to just change I2 over 1. Okay, this one we call current ratio. Okay, A for current ratio. Okay, summary. A greater than 1. So if A greater than 1, means that V2 over V1 is greater than 1, means that V2 is higher than V1. Okay, V2 higher than V1. Okay, V2 bigger than 1, so we call that one step up transformer. Step up transformer. If A less than 1, means that V2 is less than V1. V2 less than 1 is secondary side less than primary side. The previously V2 for A greater than 2, the primary side, secondary side greater than primary side. So this one is higher than this one. So that means voltage is increased. Voltage is increased, so step up. For A less than 1, A less than 1 means that V2 over V1 less than 1. So V2 is smaller than V1. V2 smaller than V1 means that the step down transformer. Okay, if A equal to 1, this one we call isolation transformer. Okay, isolation transformer means that A equal to 1 means that V at secondary same as V at primary. So V secondary divided by V primary equal to 1. Okay, both voltage same. That one is for isolation transformer. Okay, I think that's all for transformer ratio. Okay, thank you. See you later. Bye bye.